Alright, what's up guys? In this video, I'm going to pick up some multivariable calculus. We're going to be talking about triple integrals over rectangular boxes. So we're asked to evaluate this triple integral here, x, y, z to the fourth dv, where E is the rectangular box. So the best thing, most important thing you need to remember about triple integrals as it pertains to integrating over boxes, over rectangular box. Triple integrals have 6 possible orders of integration that can be used. In this particular circumstance, I'm just going to integrate kind of alphabetically in a sense. I'm just going to integrate dx, dy, dz. So we just got to set the integral up right, and that's pretty much all that it requires. So let's just get into it. So this is the integral that we have. So it's going to be x, y, z to the fourth power dv. And if we want to integrate dx, dy, dz, you have to make sure you're matching the integral up with the correct differential. So that means that the outermost integral here will be from 0 to 5. The innermost will be from -2 to +3. And then the second innermost. And then the innermost one will be from 0 to 1. And again, I'm doing this dx, dy, dz. So and this is where we're at. So it's just a triple integral. So remember, we'll integrate respect to x first, treating the other two variables as constants. Then we'll integrate respect to y, treating z as a constant. Then we'll integrate respect to z, work our way from the innermost integral to the outermost one. So we'll begin by doing that. Since we're integrating respect to x first, that means that yz to the fourth can come out because that's a constant. This would be from 0 to 1. Then we'll have x dx. And so this becomes yz to the fourth power. And we'll have x squared over 2 if we apply the power rule. And it'll be from 0 to 1. So it'll be 1/2 minus 0, which we know gives us 1/2. We'll multiply that by yz to the fourth power. And so if we do that, we can now move on to our double integral now. So it'll be from 0 to 5, from -2 to +3. And then this time, we'll have yz to the fourth power all over 2. And it's going to be dy dz. Okay? All right, so since we're integrating with respect to y now, which we're going to be doing from -2 to +3, what can be pulled out is the z to the fourth over 2. So you can imagine that I took this part out, and then that means that y is left in there. So now this becomes z to the fourth over 2. And this will be y squared over 2, evaluated from -2 to +3. So this looks like we'll get 9 over 2. Looks like we'll get -2. Okay, 9 over 2 minus 2, that's 5 over 2. But again, I always like to check and make sure I'm not wrong on that. And I highly recommend you do this as well. If you're not completely sure, then you should be checking. 1 over 2 minus 2. Just want to make sure. Yeah, 5 over 2. Just want to make sure. All right. So now what we'll do is we'll take our z to the fourth over 2 and multiply that by 5 over 2, and we'll integrate that with respect to z. And so in that case, 5 over 4 is a constant, can be brought out. And then we'll have the integral from 0 to 5, and that'll leave us with z to the fourth dz. So this becomes 5 over 4 z to the fifth over 5 from 0 to 5. So we substitute in the 5 first and the 0 after that. So we already know we're going to get when we sub in the 0, so we just sub in the 5 and plug that in. So we'll have 5 to the 5th power divided by 5. That's going to be 625. So if I do that in my head, sticking in a 0 just gives me 0. And let me check that. And you should be doing this as well in class. If you have to guess about what the answer is, there's a good possibility it could be wrong. So you should be plugging that in your calculator, which is exactly what I'm going to do to verify that I was right. Yes, I was. So please make sure you're doing this. I see so many students losing unnecessary points, because they don't want to go back and check their answers. It's okay. You using a calculator to check your answers does not make you stupid, doesn't make you dumb, doesn't make you any of that. If anything, it makes you a smart math student to plug stuff into your calculator. So it looks like when we multiply, looks like we'll get 3,125 all over 4, which I'm pretty sure can't be reduced. Because if I can't divide 3125 by 204, we'd have to leave it alone. I can, but I get a decimal. And let's try 4. And if we can't reduce it by 4, then we get a decimal as well. So we're going to leave it as 3125 over 4. So your final answer for this triple integral when we integrated it over the rectangular box, it's going to be 3,125 all divided by 4, which is a decimal. You can put that in there and figure out what it is in decimal, but you don't have to. And that would be your answer. All right. So I hope that made sense. So let me know if you got any questions about how I got my answer. I'll be more than happy to share it with you. I'll see you next time.